Let's talk about the tutorial on the big data apps and analytics. And here we are talking about how to perform the sentiment analysis task on the data provided by the instructor. Uh, as a first step, we import the necessary libraries. These are not all libraries that we have used. There are more libraries we used. We will import them as needed. But natural language processor is the main library that we have used here. So let's download it. So it is everything is downloaded on my collab space workspace. Then we fetch the data, and this link actually it is provided by the tutorial, our instructor. Let's view the data as a next step. So you can see that there are 31,962 rows and 3 columns. So let's do some data reduction. I have practiced this step of data reduction, although I have not used the data in this form because I use 2 columns in the data, label and tweet. So let's go to the next step. What I have actually done for this tutorial, I have created a reduced data frame with selected columns. So I have selected label and tweet, created a local copy, and then I imported NumPy and regex tools. Then I wrote a method that actually removes some texts by the pattern, because as a first step we removed the unnecessary Twitter handles in this case. So we have applied it to the Twitter text, and you can see that I have not only reduced the data, but also I have created another fresh column, the clean tweet. I kept it, yeah, I added it to the existing data frame. Why? Because to uh, make a scope to compare. So I have, so this is my code and this is the result. Let's run it. Now, as the next step of data cleanup, I remove the punctuation, special characters, and numbers. This is done as follows. So you can see uh, the special characters, punctuations, those are removed. See this line. As a next step, we remove the stop words as well, and we use the English word. So this is the stop words are now removed. Then we tokenized the tweets. We use the lambda functionality, and you can see the tokenized data. This is an array, and then we added back the tokenized data to the clean tweet again. So once we do that, the clean tweet looks like that, but it's tokenized. Then as a next task, we do the word cloud to find the most frequent words uh, in the application, in the data. So it takes a little bit of time to run. So word cloud actually gives a visual feeling of the data content, and the most frequent word is usually highlighted with the largest size of font. So we have also used matplotlib as a plotting library, and we disable the plotting axis because those are not necessary. We just want to have a visual feeling of the data. In this case, it takes a little bit of time, so let's see what happens here. So here you go. You can see the most I mean general sentiment of the tweet is non-racist or non-sexist. So then we find for specifically uh, the good words. So you can see it's running again, and you can see it's more elaborate. And then you have the offensive tweets. You can see the offensive tweets. It is classified according to the label field. Finally, let's see some hashtag impacts of the hashtags. So first, collect the hashtags. I've defined a function, user defined function, and then created a set of frequency distribution for regular, negative, and then I plotted the regular uh, tweets. You can see the love is the most prominent word. So this is the regular tweet, whereas the offensive tweet, you can have some different set of hashtags. Finally, I want to do some modeling. Before modeling, the pre-modeling step, I do some feature extraction, TF, IDF features. So I use tfeed vectorizer utility, and I applied this transform, uh, and also I have used the bag of words feature as well. Uh, and then finally, I utilized the clean tweet and did the word embedding, applied the gensim word to vec model utility, and I trained the data. My test size is where my test size is 70% of the train size is the 70% of my data. So you can see the model outcomes. See, if I have a word dinner, then these are the related words. Also for food, these are the related words. And then finally, I do I do some real model building. So first, I let me fix it first. Uh, so this is the plot. Oh, it's coming from there. I think here you go. So we have the code running. Now we are creating the frequency distributions. After frequency distribution, we have the bar chart. Yes. And then we have the feature extractions, the bag of word features. Then we embedded the word and gensim word to vec model. So it takes a little time because it runs through different iterations. So it first tokenizes the data, and then it runs on this tokenized data. Still takes a little bit of time. Yeah. So then you can see the performance, and then we find the similar words with for dinner. You can see spaghetti, I mean all those words. And also for food, you can see this also. So this is the model outcome for each word, I think. Then we do some real model building. First we train. um, we use some train test split facility, and you can see that our test size is 30%, train size is 70%. So we train 70% of the data, and based on that training we test 30% of the data. And you can see from the test, uh, from the training, we do some predictions with a F1 score, which says the test's accuracy 51%, for backup word it's 51%, whereas for TF IDF it's 53%. So it's TF IDF is better. So we did, so I've learned how to use the natural language processing. Uh, then after processing, doing the data reduction. So the basic steps: first we do some data cleanup, then we extracted the features of the data. We did several visualization tools like word clouds and bar charts, and then finally we focused on train test train splits of the data. This is a very nice concept. You use the same data to train itself, and then we applied that result of the test train method to the actual prediction on the test data itself. And we find that the according the training, the prediction is, the predictive accuracy is 51% for backup word model, and 53% for TF IDF model. Basically it's a small data set, probably due to that the tests are trainings are not that accurate. With larger set of data we expect more accuracy. So that's all from me now. Thank you.